Hello everyone, so let's talk about surround region. So in this question, I'm going to solve this question by union find. So union find is actually a quick way to do that because they are beneficial of doing this when you're trying to find a node that you share with someone else before. Like they will take you all of one for time complexity or not, right? And that's just basically like you have to assign a number of the node to yourself, right? So you will have n nodes, and for each node you are going to point at yourself. And when you union, right, you can actually union A node to B node, right? If A node and B node do not have the same parent or same grandparent, then you assign one node to the other. So for node 2, right, node 2 will point at node 1. So node 1 become the parent of the node 2. So this is how it is. And find is actually to check which one is my top grandparent. It should be like this, right? So which one is the top node I have a connection with. This is how you actually do it. You can actually return yourself, right? You can actually return to yourself, or you can still keep going up, right? And for its connected, it's going to check, are these two nodes connect with the same node on the top above, right? If yes, you're going to return true. If not, you're going to return false. So how do I solve this question by union find? Is I convert every cell to a node, and then I'm going to assign for each node to a node where it is supposed to be a node, which is not going to flip. If the node is going to be flipped, it's going to be X. If the node is not going to flip, it's going to be circle. This is how it is, right? You can watch my depth first search video. Depth first search video, it will be easy for sure, but I'm going to practice a union find. So let's start get it. So I'm going to check the board. If then board.length is equal to 0, then I'm going to return. And also I'm going to assign row and column to my column and row value. So I'm going to say union find. I'm going to declare the value UF equal to new union find. So how many nodes is going to be rows times columns, right? But I want to add one. When I want to add one, is because I want to know, I want to create another node that is going to be a node that is represent circle. Okay, so I'm going to say dummy. Dummy will be the rows times columns. This is going to be a number, and since the value for each node is going to be 0, 1, 2, something, right? So it starts from 0, and dummy will be the last integer on this board, right? So this is unique for sure. I'm going to traverse in I equal to 0. Sorry, I equal to 0. I less than rows, I plus plus. For in j equal to 0, j less than column, j plus plus. All right. So I'm going to say if board ij is equal to O, and I'm doing something else, I'm doing another things. So if board is equal to O, right? And I'm going to check the border first. If the border is equal to circle, so ij is equal to O, okay? But I also have to check the border. If I equal to 0 or j equal to 0, or I is equal to row minus 1, or j equal to columns minus 1. Okay, if this is going to be true, right? This is going to be true. The border, if the border is going to be a circle, and I'm going to assign to a dummy, so union, so uf.union, and the value for these cells I'm going to assign, I'm going to create another function which will give you node in I in j. Oh, where's my mouse? In I in j. I'm going to return I times column plus j. This will represent like your number for each cells, which is your node. Okay, so union. So I'm going to union your node, which is I and j, right? So node I, j with the dummy. So this is going to be a value, a cells that is going to be a circle. If the cell is a circle already, right? When you flip the board, right, it's going to be a circle again, and that will be it for board I and j. Okay, and I don't have to do the else for this case. But what happens if the cells is equal to circle, but it's not in the boundary of I equals 0, j equals 0, I equals rho minus 1, j equals rho minus 1. I will definitely need to know if the cells, if this cells is connected with the border. So if this cells is connected with the border, top, left, or bottom, or right, if this cell is connected with the border, I need to know, I have to connect with it. Because this cell is circle, right? Imagine this cell is circle. So I need to know if this cell is circle, I need to connect with the border, and all those cells has to connect with the border. So if border I minus 1 j equal to O, I do something, right? And I can use else, but I want to just making sure if I plus 1 j is equal to O, I do something. If board, so you can see this will be j plus 1 and another one j minus 1, right? J minus 1 is equal to O. You do something else. So how do you actually union with the border? So you're going to say uf.union, and you are going to say your current cells. Your current cells. You're going to union. You're going to find the node, which is I minus 1, comma j. You're going to union with it because that is the border, right? If I equal to 1, I minus 0, this is border, right? So you're going to union. So same idea, uf.union, node ij, this is going to be comma and comma node, and then you're going to say node I plus j and j. So this will be exactly similar. And node ij, simple, node ij plus 1. And uf union, node ij, comma, node I, j minus 1. Okay, that will represent the connection between the cells with the border. So when you assign everything on your board, right, you can convert every single cell to the node, and then you connect every single node to something else, right? Then you can actually going to check. So I'm going to traverse again. So if uf is connect, if this is connect, if the single cell is connect ij with a dummy, because I already know, I already assigned to a dummy, if this cell is dummy, if this node is dummy, it's going to be circle, right? So board ij is assigned to circle, else board ij remain x. This is how it is, right? And I hope you understand, and let's just run it to see if I have error or not. Okay, I do. So I made a mistake. ij, okay. Okay, rows, tiny columns. Okay, spelling wrong. Let's just see again. Oh my god, so many. Okay, so I need this column, and yes, sorry. So I'm gonna assign my rows and column for global variable, and these two variable will just going to be initialized over here, and they just run again. It should be passed, yes. And it should be okay. So let's talk about time and space. And for every single cells, you have to traverse once, right? So that would be all of m times n. So that would be time complexity. And for every single space complexity, for space complexity, you have to store every single node in the union point, right? So that would be all of m times n. And time and space complexity are the same, so that would be the solution. And this question is pretty standard for practicing the union point. And if you're not comfortable with, you have to spend time on it. Just making sure you know what is the union class, and just making sure you know how to connect with the node with another. And that will be the solution. And if you have any comment, just comment below. If you have any question, just please let me know. And if you like the video, please press a like and subscribe if you want it. All right, peace out.